Namaskar, welcome to the channel Anka Anandaharan, that is extracting happiness from the teaching learning process of mathematics. The purpose of these videos are to enable its viewers to do self-study of applied linear algebra from the book Linear Algebra and its Application by Gilbert Run. So today we are going to discuss about left and right inverses, also complete solutions if possible. So here A is any matrix having m rows and columns. If there exists a matrix B having n rows and m columns, so that I will get identity matrix of n rows and n columns, then B is said to be, if there exists such B, then B is said to be left inverse of A. Why left? Because it is multiplied from the left hand side. Similarly, if A is any matrix m rows n columns and I get a matrix C having n rows m columns and I am getting identity matrix of m rows m columns, then we can claim that C is right inverse of A. C is right inverse of A. So now we got the meaning of right inverse and left inverse. If any matrix is multiplied from the left hand side of A to give the identity matrix, it is left inverse. Similarly, if any matrix C is multiplied from the right hand side to give a matrix A to get identity matrix, then we used to tell that C is the right inverse. Here we can observe that any rectangular matrix or square matrix may have left inverse or right inverse. It is not necessary that the matrix should be a square matrix. It is not necessary. Next question is, when matrix has left inverse or right inverse, if rank of A is equal to R is equal to number of rows, that is equal to m. This implies and implied by right inverse exists. And if rank of A is equal to R is equal to number of columns, that is n, then we can claim that left inverse exists. This implies left inverse of, here also of A exists. So we have verified when left inverse exists, when right inverse exists. And if my rank of A is equal to R is equal to M is equal to N, This implies my left inverse, right inverse exist. Not only they exist, they are equal, and this is the inverse of A. Now the question is how to find out if left inverse exists. What will be the formula for it? If right inverse exists, what should be the formula for it? So I have a matrix A. Suppose its right inverse exists. Then right inverse C is equal to what I will write? I'll write three matrices, the three A's. Then in the right hand side, I will give a bracket and I will take its inverse. Then here I will give transpose. Here I will give transpose. There is one gap between two transposes. In the outside matrix, always I will put transpose. So it is formula for right inverse. Now formula for left inverse. Write three matrices A. Take a bracket of the left hand side and give a transpose in the outside matrix and one gap transpose. So it is left inverse formula. For example, suppose I have a matrix 1, 2, 3, 2, 3, 1. So here it is 2 cross 3. Just I will do one of the. And what about its rank? So naturally its rank is row operation. So if I will make here 0, directly I need not find out the, I need not do any row operation. Okay. So here in this case the rank is 2. So as the rank is 2, so naturally what I am getting? Number of rows. Rank is equal to number of rows. It is number of rows. So right inverse exists. Now what to do? To find out right inverse, I should multiply A with A transpose. That is 1, 2, 3, 0, 3, 1 into A transpose is 1, 2, 3, 0, 3, 1. How much it is? It is something 1 into 1 plus 2 into 2 plus 3 into 3. How much? 9 plus 4 plus 1, that is 14. Then it is 6 plus 3, 9. Then it is again 6 plus 3, 9. Then it is 6, 9 plus 1, that is 10. So it is my A transpose. Here, how to find out its inverse? We know inverse of any matrix can 2 cross 2 matrix can be comfortably we can obtain from using a formula. So what is that formula? 1 by AD minus BC. It is D, it is A, it is minus B, it is minus C. This is what? This is formula for ABCD. Its inverse. Now here in this formula, Let us substitute the value of ABCD. That is 140 minus 81. 1 by 140 minus 81, and then 14 replace 10 minus 9 minus 9. This is my this inverse. Now what I require? Now I am requiring to find out A transpose into A transpose inverse, which will give me the total result. How much it is? It is 59. 1 upon 59 taken outside, it's a scalar quantity. And what is A transpose? 1 2 3 0 3 1 multiplied with 10 minus 9 minus 9 14. So what to do? 1 by 59, let it be as it is. Then what will happen? 1 0, that is it is 10. Then it is minus 9. It is 2 into 10. 2 into 10, 20 minus 27. That is it is minus 7. And here minus 18 plus 42. 42 24. Here it is 30 minus 9. 30 minus 9 means 21. Here it is minus 27 plus 14, that is minus 13. So this is my desired result. It is my desired right inverse, that is C. Similarly, we can calculate for this matrix, as the number of columns is not equal to number of rank of the matrix, hence its left inverse does not exist. Similarly, we can verify for left inverse, and we can also find out the left inverse whenever it is required. So it is all about left inverse and right inverse. Next we will discuss about complete solution. Before going to complete solutions, we should know what do we mean by row reduced echelon form. What it is? It is an echelon form, a matrix is said to be in row reduced echelon form if it is in echelon form with each pivot as one and each element, each non-pivot element, each non-pivot element in the pivot column is 0. is 0. Okay, so it is said to be row-reduced echelon form. Now we are going to discuss about complete solution. Suppose a system of equation Ax is equal to B has this coefficient matrix A singular. If this is singular, then the system of equation has infinitely many solutions. This implies if this is singular and this, not only this, still one more sentence is to be written, and B belongs to C of A, column space of A, that is, it has solutions. We know that B belongs to C of A implies and implied by Ax is equal to B has solution. That means if x is equal to B has solution, then B belongs to C of A. If B belongs to C of A, then Ax minus x is equal to B has solution. So now here, in this case, it is singular as well as B belongs to C of A. That means this system of equation has infinitely many solutions. So here this implies B is, in this case, Ax is equal to B has infinitely many solutions. Because if a system of equation is singular, either it has no solution or it has infinitely many solutions. But here there exists one solution, at least one solution, that means it has infinitely many solutions. So now our target is to find a x so that it is represented as any arbitrary solution of this. It is representing any arbitrary solution of Ax is equal to B. So if it is representing all the solutions of Ax is equal to B in one form, then it is said to be complete solution. So here x which satisfies this equation is said to be a complete solution, where x is equal to xn plus xp. Actually in the book it is writing xp plus xn. So let me write out in that format, that is xp plus xn. So here what is xp, what is xn? Where xp is a particular solution of Ax is equal to B. That is AXP is equal to B. This is satisfied. Then XP is said to be a particular solution of this non-homogeneous equation. And what about Xn? This is said to be, also this is said to be special solution. For any vector, its null space vectors are said to be special solutions. So here they are also called as special solutions. And what about xn? What condition it satisfies? Axn is equal to 0. So this is one, this is another. So from these two equations, any x written in this format is said to be a complete solution. Here different values of xn, because A is a singular matrix and Axn is a homogeneous system of equation, it has always infinitely many solutions. Hence, we will have a vector space or solution space of xn is equal to 0, its basis vector plus a particular vector, solution vector, will give me complete solution. Now how to find out them? So here our target is to find out xp, then xn, and write it as x is equal to xp plus xn. First step, write the augment matrix. There is an example given in the book. We will do that. The system of equation considered here is 1 3 3 2 2 6 9 7 9 polyol. So let me verify what happens. Then it is 1 minus 1 minus 3 3 4. It is 1 5 5. Let us consider this is this into u v w y vector এটাতে কষ্ট হবে না. So just I have to erase some part to save time. I was trying, but it will give confusions. So better we will take few more seconds. So this into u v w y, it is 3 cross 4 4 cross 1, it is 1 cross 3 cross 1, that is 1 5 5. This is given to us. Now with this system of equation, first of all we'll verify that they are this system of equation is having the matrix is singular, coefficient matrix is singular, and it has solution, and it will have, we will verify first. So step 1, write the augment matrix. What is it? 1 3 3 2 2 6 9 7 minus 1 minus 3 3 4. This into this side it is not into, we will augment it with the RHS vector, that is the RHS vector 1 5 5. So write down the augment matrix. Step 1 is over. Next is apply elementary row operations on this matrix to get row reduced echelon form of the coefficient matrix. So what should we do? I will write R2 minus 2R1 stored in R2 and R3 plus R1 stored in R3. What I am getting the matrix is, it is first row no change, so first row just I will copy 1. Second row, twice this first row is subtracted from second row, it is 0, it is 0, 9 minus 6 it is 3, 7 minus 4 it is 3, 5 minus 2 it is 3. Now I will add, it is 0, it is 0, it is 6, it is 6, it is 6. So next is, this is my first pivot, below it I got 2 zeros, so first pivot is over. In the first row no pivot can be there. From the second row, because this position is 0, so this is the first non-zero element, it is my pivot. As I am interested to find out row reduced echelon form, that means this element and this element both I will make 0. So I have to do two operations. What are those two operations? R1 minus R2 stored in R1. Second is R3 minus 2R2 stored in R3. Let us do these two operations. What we are getting? 1 minus 0, it is 1. 3 minus 0, it is 3. 3 minus 3, it is 0. 2 minus 3, it is minus 1. 1 minus 3, it is minus 2. Now, it is no change, no effect. 3, 3, 3. Then 0, 0. 6 minus 6, 0. 6 minus 6, 0. 6 minus 6, 0. So I got it is having only two pivots. So it is a singular matrix. This is a pivot. This is another pivot. But still it is not in row reduced echelon form because there is a pivot. So one condition is over, that is in the pivot column. So it is a pivot, first column is a pivot column, no other element is non-zero. Other than the pivot, all other elements are zero in the third column also. So now my target is to make it in row reduced echelon form, that is I should divide the second row by 3. 1 by 3 R2 stored in 1 by 3. Stored in R2. Sorry. Stored in R2. So how much it is? It will give me 1, 3, 0, minus 1. It is minus 2. It is 0, 0, 1, 1, 1. It is 0, 0, 0, 0, 0. Okay. So now it is in row reduced echelon form. To find out XP, first step is I have to verify my pivot variables, free variables. This is first column for first variable, second column for second variable, third column for third variable, fourth column for fourth variable. Clearly, what are my pivot variables? U, V, W, Y. So U is a pivot variable. Here there is a pivot and W is a pivot variable. So it is my pivot variable. To find out XP, what I have to do? I have to substitute. Here it is my free variable, it is my free variable. In all the free variables, to find out XP, what should I do? In the free variables, I will give values 0. And I will substitute in the equation and to get the pivot variable. But if this matrix is in row reduced echelon form, if it is in row reduced echelon form, then directly we can calculate that pivot variable value. Here U is a pivot variable. It is located in the first row. It is pivot in the first row. So the first row of RHS vector is minus 2. U value is minus 2. Similarly, W is a pivot variable and it's a in the row, second row it is containing. So second row RHS vector is my W value. So I got my 4 variables. So I got my XP. What is my XP? U, V, W, Y. Is equal to minus 2, 0, 1, 0. If in the examination hall the formula is forgotten, then also from this equation, this row reduced echelon form of the matrix is said to be R. So Rx is equal to this B star. From those equations also substituting the free variables 0, we can calculate the pivot variable. That is, from the equations W plus Y is equal to 1 u plus 3v minus y is equal to minus 2. So from these two variables, substituting the free variable here 0, here 0, here 0, we can calculate the pivot variables. There are two options. In case of xp, the free variables should be assigned value 0, and pivot variables we usually obtain from the RHS vector corresponding to the pivot variable. If it is in the first row, then the first row element. If it is in the second row, then the second row element of the RHS vector gives me the value of the corresponding pivot variable. Next is how to find out xn. To find out xn, we have to first take this r x is equal to 0. We have to solve it. So how to solve? What are the equations? That is, the equation is u plus 3v minus y is equal to, specifically I want to show it, that's why I am writing here the right hand side 0. People used to forget this. It is 0 vector. They used to write everything. Whatever right hand side is there, they used to substitute, and finally it is a wrong answer. So here what we will do? It is, another equation is w plus y is equal to 0. Now let us substitute the free variable and pivot variable. What we will do? U, v, w, y. This is pivot, this is pivot, this is free, this is free. One free variable assigned to get xn, free variable is assigned with 1, other is 0. Similarly, other free variable is assigned with 0, and this is 1. Now substituting these values in this equation, we get our pivot variables. What is it? In this case it is 0, in this case it is minus 1. Now substituting these variable values in this equation, what we are getting? V is 1, so it is minus 3, and y is 1, so it is 1. So I got two null space vectors of the given matrix, that is coefficient matrix. But writing again, the xn is having some specific property. So here while writing, I am leaving some space intentionally. This is minus 3, 1, 0, 0 plus, again I am leaving some space, 1, 0, minus 1, 1. Now I will verify, while getting this matrix, which free variable is assigned with 1. So this is the free variable which is assigned with 1. So this free variable corresponding variable I will write here. Similarly, while getting here, this free variable is assigned with 1. So it should be multiplied with y. Why it is so? To get any null space vector, suppose I have null space vector minus 2, 1, minus 1, 1. Okay, suppose this is a null space vector. Now my target is, I want to, suppose its name is E1, its name is E2. I want to write this vector as a linear combination of E1 and E2. So this is this into something into E1 plus again something into E2. What is that something? So here there are two free variables. When I am writing here V, that means when E1 is to be multiplied, I will observe what is the value in the second component position. Here in the second component position, it is 1 is written, so it is 1. Similarly, to here y is written. So what is written there in the fourth position, I will verify whatever here it is. It is in this vector, it is 1. So y in place of y, I will write this one. Now, for example, another. Suppose I will multiply here 2 and here 3 and I will add them to get the vector. It is minus 6 plus 3, so minus 3. It is 2. It is 0, 0. So it is minus 2. Sorry, it is minus 2. It is minus 2, minus 3. Sorry. Control. It is 2. It is minus 3. It is 3. So what process we have done? We have multiplied 2 with E1 and 3 with E2. Now observe this position. V position is having value 2 and here Y position is having value 3. So any arbitrary vector of the null space can be written as a linear combination of E1 and E2 very comfortably just by locating the free variables and substituting the value of that variable. Okay, so with this we got xn, and why xn is written in this format, that is also understood to all. So now what is my xp? X is equal to complete solution is equal to xp plus xn. What we got in our xp? Minus 2, 0, 1, 0. Minus 2, 0, 1, 0. This is my xp and xn is just written here. So there is no confusion at all. How much I will write? It is v times minus 3, 1, 0, 0 and y times plus y times 1, 0 minus 1, 1. How to get this y and v? They are the free variables which are assigned with 1 while getting those vectors. So while getting these vectors, the free variable assigned with 1 is v. So I have multiplied here v. While getting this vector, the free variable assigned with 1 is my y. So I multiplied with y. So this is all about the complete solution of a singular system of equation having solution. So we should stop here. I hope you have understood. All of us are not having any ambiguity or confusion. If at all it is there, then you can ask. Now the question is, with this, should we stop? The answer is yes, because it will be, otherwise it will be a long video. So thank you for your patient listening. Thank you.